The first type of device we're going to meet in this chapter is an ammeter. And an ammeter is a device that measures current. And the way you can remember this is that am can be used to mean amp, which is really ampere, but we all just say amps. So am is for amp, which is the unit of current. Now, you always want to have your ammeter in series with other components. So for instance, if we want to say what is the current through this 6 ohm resistor, what we need to do is put the ammeter in series with that resistor so that whatever current is flowing through the resistor, remember that current is conserved, also flows through the ammeter. So if we actually put the ammeter down here, we would get the exact same current. Those would be the same things. So the ideal ammeter has a resistance of 0. Why is that? Well, we know that the current coming out of this battery, I, is going to be equal to the EMF of the battery, assuming that it's an ideal battery, divided by the resistance of the circuit, where here, that's 6 ohms. If the ammeter actually added resistance to the circuit, then you would have to add the resistance of the ammeter on the bottom here, and that would actually change the current. That's bad. You don't want to change the current, you just want to measure the current that's already there. So we actually approximate and say that the resistance of the ammeter itself is 0. Now, this is a simplification. The actual resistance of the ammeter is going to be a few ohms. So as long as the resistance of the other pieces of the circuit is much bigger than this, it's fine. One thing to note is that many of the values given in your book, for instance 6 ohms, is not actually the size of a resistor you would ever see in a real circuit. So typically resistors in circuits are going to be hundreds of ohms, thousands of ohms, potentially hundreds of thousands of ohms, or even millions of ohms. And the reason that it's important to note that is that when we say that our wires are ideal, in that case we're saying that we can neglect the resistance of our wires. The wires themselves have a few ohms of resistance. Similarly here with the ammeter, we're choosing to ignore its resistance where it has a few ohms of resistance, and that's reasonable, though it doesn't necessarily seem reasonable if your resistor in the circuit is 6 ohms. So a better way to think about this is actually for this to be, for instance, 600 ohms. Given that resistors only have a tolerance, an accuracy of about 5%, that means that if we're only adding or subtracting a few ohms from this, we don't really mind, we don't really care. So think about that. Again, the book sometimes uses unreasonable values of resistance, but I in general on homework and test questions will try to give you reasonable values. And so it will be reasonable, therefore, to assume that we have an ideal ammeter with a resistance of 0.